Alright, what's good everyone? So this video is really just a continuation of the intro to cross-validation. We left off there saying that we wanted our kind of residuals from this holdout sample to be like good. And so we need some sort of definition of what good means. And there are many different quantities that you can compute from these residuals to kind of see how your model is predicting. We're just going to talk about 5. And so we'll just kind of list what each of these are as well as what we're looking for. And so the first thing that we might look at is the mean of the residuals from this holdout sample. So remember, residuals are in quotes because they're not really residuals in the traditional sense. And so what we're looking at there is we're just adding all the residuals up, dividing by the sample size, where n is the number of observations in the holdout sample. Okay. And so we're really just looking for this mean to be close to 0, because far from 0 indicates that the model is either over if it's bigger than 0 or under if it's less than 0, estimating the response in the holdout sample, which is bad. So we want it to be close to 0. How close depends on what the units of y are, but that's generally what we're looking for. We could also look at the standard deviation of the residuals from the holdout sample. And so the standard deviation would be that. And for this quantity, we're just checking that it's somewhat close to the standard deviation of the residuals in the training sample model. So that was sigma hat epsilon. If it's much larger than that, then that's kind of telling us that for some reason there could be outliers, influential points, it could be another reason. But for some reason, the model is doing a lot worse for the holdout sample than it is for the training sample, which also isn't good. The last 3 have to do, like if you were to compare a couple of models, how good the predictions are from those models on the holdout sample. So the maximum absolute deviation is just the worst prediction. And this is just indicated by the largest residual. So largest in absolute value in the holdout sample. And so lower is better, right? We want our largest residual to be pretty small. Root mean square prediction error, so that looks kind of similar to the standard deviation of the residuals. But for this, we're just looking for this to be low. Because if this is low, then that means a lot of the observed responses are close to the fitted responses based on our model, which is good. And then finally, there's the mean absolute error, which is the average error regardless of sign. So that's what it would be as a formula. And again, for this, we're looking lower to be better, because if this is lower, then that means a lot of the observed responses are going to be close to what's predicted based from the model. So we could find each of these quantities using our holdout sample. We're never going to calculate them by hand. We're always going to let R do the work for us. And so you'll get some practice doing that with the FAT data set in this R Markdown notes. And you'll get even more practice using our project 4 with the Spotify data.